For over 60 years, chemical rockets have been the backbone of space exploration, getting us to the moon and beyond. But when it comes to sending people to Mars, they're stretched to their limit. A trip today means a grueling 6 to 9 month journey, exposing astronauts to dangerous levels of space radiation. But what if we could slash that travel time? A technology proven decades ago is making a comeback, one that uses the raw power of a nuclear reactor to build a rocket that's 2 to 5 times more efficient than anything today. This is the ultimate showdown: chemical rockets versus nuclear thermal propulsion. Chemical rockets work using controlled explosions. You take a fuel and an oxidizer, ignite them, and the resulting hot gas creates massive thrust. Their efficiency is measured in specific impulse, and the very best top out around 465 seconds. To go faster, you have to pack more fuel, which makes the rocket heavier and less efficient. A nuclear thermal rocket, or NTP, works differently. Instead of an explosion, a compact nuclear reactor heats a single propellant, like liquid hydrogen, and blasts it out of a nozzle. This is far more efficient, achieving a specific impulse of 900 seconds or more, at least double that of chemical rockets. This isn't science fiction. The US proved the technology worked with Project Nerva in the 1960s. For a Mars mission, that difference is night and day. A nuclear rocket could cut the travel time from 9 months down to just 4 or 5. That's a huge deal for astronaut health, dramatically cutting their radiation exposure. This potential drove NASA and DARPA to create the Draco program to test a nuclear engine in space. But in a surprising twist, the in-space test was canceled. The reason wasn't a failure of the technology. Instead, the game was changed by the rise of massive, reusable chemical rockets. As companies like SpaceX drove down the cost of getting to orbit, the financial argument for nuclear began to crumble. Why spend billions developing a new engine when you could just launch a much larger, fully fueled chemical rocket for a fraction of the cost? The problem was suddenly being solved not with more efficiency, but with sheer scale. So, where does this leave the race to Mars? Reusable chemical rockets are our powerful here-and-now solution. Nuclear propulsion remains a game-changing technology that holds the key to faster, safer human missions into deep space, just waiting for the right moment to be unleashed. The race to Mars is still on. What technology do you think will take humans to Mars? Let me know your thoughts in the comments below. And if you enjoyed this look into the future of spaceflight, be sure to like this video and subscribe for more.